Mars is not red, it is the color of butterscotch. Seen from Earth with the naked eye, Mars is a steady orange point, and every old civilization that wrote anything down noticed it and connected it with blood or with war. Stand on it, and the color is gentler than that. The ground is a dull tan, the shade of butterscotch or weak tea with milk. Photographs from the surface that have been carefully color-corrected show a landscape that would look ordinary in a desert on this planet. The color comes from a very thin coating. The dust that covers almost everything contains iron oxide, which is rust, in grains finer than talcum powder. It is a few micrometers thick in places, and it is everywhere because the wind has been sorting it for billions of years. Underneath, the rock is dark gray basalt. Where a rover wheel scrapes the surface, or where the wind has swept a slope clean, the planet is the color of a cold beach in the north. We are confident about this because every rover carries a calibration target, a small plate of known colors bolted to the deck, photographed alongside the landscape. It exists purely so that the colors in the pictures can be checked against something certain. The sunsets, they are blue. On Earth, the sky is blue and the sunset is red. On Mars, it is the other way round, and the reason is the same physics working on different material. Our air is clear, and the molecules in it scatter short blue wavelengths in all directions, which paints the whole sky blue. At sunset, the light comes in through much more air. The blue is scattered away, and what is left is red. Martian air is thin, but it is loaded with those fine dust grains. Grains that size scatter red light strongly and sideways, so the daytime sky is a pale butterscotch color all over. Blue light passes through the dust more directly instead of bouncing away. So near the setting sun, where you are looking straight down the beam, the light that survives is the blue. A cool blue glow spreads around the sun for a diameter of several times its width, and it lingers because dust stays suspended a long time in weak gravity. There are images of this taken from the ground, and they are among the strangest pictures in the archive precisely because they look so calm. A small white sun setting into a hazy tan desert with a patch of cold blue around it. A day on Mars is only 40 minutes longer than ours. Of all the coincidences in the solar system, this is the one that makes Mars feel closest. Mars turns once in 24 hours, 39 minutes, and 35 seconds. That period is called the sol. Its axis is tilted by about 25 degrees, which is within a degree or two of ours, so it has the same 4 seasons for the same reason. The differences are in the length of things. The year is 687 Earth days, so each season is roughly twice as long. The orbit is noticeably out of round, which makes southern summers shorter and hotter, and northern ones longer and milder. There is a practical consequence that people who work on Mars missions know well. A rover team on Earth that wants to work while its rover is in daylight has to shift its own working day 40 minutes later every day. After a few weeks, they are arriving at the office at 3 in the morning. Teams did this for months on end during the early rover missions, with watches specially built to run slow. We know the rotation to a fraction of a second by tracking fixed features, and by radio ranging to the landers, which have been sitting still on the surface for decades.